be discussing the orthogonal system of unit vectors, and then we shall discuss the scalar product of two vectors, that is also termed as the dot product. We shall discuss how do you exactly calculate the dot product of two vectors and do practice a good number of questions on it. We shall discuss various properties as well as some questions based on the concept. So stay tuned.
Okay, so the next topic that we have is the orthogonal system of unit vectors. Let OX, OY, OZ be three mutually perpendicular straight lines. You can see here in the figure OX, this is OY and this is OZ. These are three mutually perpendicular straight lines. Then given any point P, X, Y, Z in space, we can construct the rectangular parallelepiped of which OP is a diagonal and OA is X, OA is X, OY, OB is Y, right, and OC is Z. Here ABC are coordinates. If you try to find out the coordinates of ABC, obviously you will get it as x0, 0, 0, y, 0 and 0, 0, z respectively, because on this, on x-axis y and z coordinates would be 0, and similarly on y and z axis also. And LMN coordinates are O, Y, Z, X. So the here ABC are x0, 0, O, 0, y, 0, 0, 0, z respectively, and LMN are 0, y, z, x0, z, x, y, 0 respectively. Now I, J, K cap denote unit vectors along OX, OY, OZ. Then we have the vector R as the vector OP, that would be x I cap plus y j cap plus z k cap. This also we have already discussed that OA is xi cap, OB is yj cap and OC is zk cap, and therefore you get the vector R as sum of these three vectors. Now R is the modulus of vector R, that is modulus of vector OP is under root of x square plus y square plus z square, and therefore the vector R becomes now R vector by modulus of R. This is equal to xi cap plus yj cap plus zk cap by under root of x square plus y square plus z square, that is li cap plus mj cap plus nk cap. So we can write the vector R as lri plus mrj cap plus nrk cap. Okay, so do not get confused seeing all this theory. This is just for your understanding sake. What you need to remember is just these three things, that L is equal to cos alpha, that will be equal to x by under root of x square plus y square plus z square, where alpha is the angle between OP and x axis. So the angle between OP and x axis is alpha, so we get L equal to cos alpha, and the value is x by under root x square plus y square plus z square. Similarly, you will get the values of m and n, that is cos beta is y by under root x square plus y square plus z square, where beta would be the angle between OP and y axis. Similarly, n would be cos gamma, that will be equal to z by under root x square plus y square plus z square. Gamma is the angle between OP and z axis. Elements are defined as the direction cosines of the line OP, and x, y, z are defined as the direction ratios of the line OP. So these things are important, that element are direction cosines, while x, y, z would be direction ratios of the line OP. If P is the coordinate x1, y1, z1 and Q coordinate is x2, y2, z2, then PQ, it becomes x2 minus x1, this coordinate minus, this coordinate, x2 minus x1, then second will have y2 minus y1, and similarly z2 minus z1 into I cap, j cap, k cap. Therefore PQ will become under root of x2 minus x1 square plus y2 minus y1 square. In fact, this you can get easily by using the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, entire under root. Direction ratios of the line P and Q are x2 minus x1, y2 minus y1, z2 minus z1, and its direction cosines are x2 minus x1 by PQ, y2 minus y1 by PQ, and z2 minus z1 by PQ. In fact, here we shall also discuss some of the properties, important properties of direction cosines and direction ratios. Okay. So LR, MR and R are projection of R on x, y, z axis. Secondly, R we have already discussed is Li plus Mj plus Nk. Then L square, since these are direction cosines, so L square plus M square plus N square is 1. You must be knowing by the property of direction cosines it follows. And then we have A, B, C are if A, B, C are three real numbers such that L by A is M by B is N by C, then I'll write it here. Then what do we have? A, B, C are DRs, direction ratios of the line whose DCs are L, M, N. All these follow from the properties of direction ratios and direction cosines, that L square plus M square plus N square is 1 in case of direction cosines. Then if A, B, C are three real numbers such that L by A is equal to M by B is equal to N by C, then in that case A, B, C would be the direction ratios of the line whose direction cosines are L, M and N. Okay, so now we have the scalar product of two vectors, that is called as the dot product. This is an important concept. The scalar product or dot product of two vectors A and B is denoted as vector A dot vector B. That is why it is called as the dot product. It is defined as a product of their magnitude with cosine of angle between them. Thus, this is what you need to remember. Vector A dot vector B, or the dot product of vectors A and B, is given by A into B cos theta, where theta is the angle obviously between the vectors A and B. And what about the properties? Again, the properties are important because they clear up your concepts about the scalar product. It is always a scalar quantity. The dot product of two vectors is a scalar quantity. It is commutative. A dot B is equal to B dot A. Just try to remember these properties. We will also discuss the concept of cross product in future. So do not get confused in these two. So dot product is always a scalar quantity. Then it is commutative, that is A dot B is the same as B dot A. It is distributive, that is A dot B plus C is equal to A dot B plus A dot C. And by definition we have already discussed dot product of A into dot product, A dot B is equal to AB cos theta. The angle between vectors theta, therefore from this only you can derive, becomes theta is cos inverse of A vector dot B vector divided by AB. Again, the continuation of properties. A dot B is A into B cos theta, which can be written as B into A cos theta. Scalar product of two vectors will be maximum when cos theta is maximum, and that maximum value of cos theta is obviously 1. Again, cos theta is 1 means theta is 0, and as we have discussed earlier also, theta is 0 means the vectors are parallel, and therefore the maximum value of A dot B becomes AB. How? A dot B was AB cos theta. Now cos theta is 1, so this becomes AB. So maximum value of A dot B is AB. If the scalar product of two non-zero vectors vanishes, then the vectors are orthogonal. This is important. If the dot product of two vectors, non-zero vectors obviously vanishes, then you can easily get that the vectors are orthogonal. In case of orthogonal unit vectors, that is I cap, j cap, k cap, I dot j is equal to j dot k is equal to k dot I is 0. This is again important. These are important because these concepts will be utilized in solving various questions. So just try to concentrate on these properties, just try to understand these properties. Okay, the first question that we have is, find a vector of magnitude under root 51 which makes equal angles with the vectors Okay, we are given 3 vectors and we are required to find out a vector of magnitude under root 51 which makes equal angles with these 3 vectors. How do you proceed? First of all I assume, let the required vector be r is xi plus yj plus zk. Then it's given that the magnitude of r is under root 51. So x square plus y square plus z square I can write is 51. This is my first equation. Now by definition what follows is r dot a is this value, right? We have just now discussed. So this gives me cos theta becomes r vector a vector by this value. In fact, similarly I can write that my this is what we have got would be equal to, similarly for B we'll have the same thing, and similar thing we'll have for C, right? R dot A by this quantity is equal to similarly for B and similarly for C, and this is equal to cos theta. Now what next? It's given okay. Now vector A is 1 by 3. This should be x I minus 2j. Okay, vector A is given to be, this should be I minus 2j plus 2k. Vector B is 1 by 5 minus 4i minus 3k, and vector C is j. So what about modulus of A? That will become 1 square plus 2 square plus 2 square by 3. This is under root. So I have 4 plus 4, 8 plus 1, 9 by 3. That's under root 9 by 3. That becomes 1. Modulus of B is again 4 square plus 3 square under root by 5. That is again 1. And modulus of C obviously is 1. So that means modulus of all the 3 vectors is 1, or magnitude of all the 3 vectors is 1, and therefore modulus of A is 1, modulus of B is 1, and modulus of C vector is also 1. That means magnitude of all the 3 vectors is 1. So that means that I get R vector R dot product of vector R and vector A is equal to dot product of vector R and vector B is equal to dot product of vector R and vector C. This is what I get, right? Hence 1 by 3 of x minus 2y plus 2z is equal to 1 by 5 of minus 4x minus 3z is equal to y, right? So this is what we have. Now from these two what I get is, okay, I can take this and this. So from these two I get x 3y minus, it becomes x minus 5y plus 2z is equal to 0, and from second and third what do I get? Minus 4x, I take it to that side, so I have 4x plus 5y plus 3z is equal to 0, right? This is what I get. Now what I can do is I can solve out these two. Just solve out these two equations, and what do we get? X by minus 15 minus 10 would be equal to y by 8 minus 3 is equal to z by 5 plus 20. So this gives me x by minus 25 is y by 5 is z by 25, or I can write it as x by 5 is y by minus 1 is z by 5 equal to lambda, suppose, right? So this gives me putting the values in first. This was my first equation, x square plus y square plus z square is 51. I put these values in that equation and so I get 25 plus 1 plus 25 lambda square is 51. So this gives me 51 lambda square is 51, or lambda is plus minus 1. Now since we have obtained the value of lambda, x becomes, this implies x is plus minus 5, because x was 5 lambda, so x becomes plus minus 5. Y was minus of lambda, so it becomes minus plus 1, and z again becomes this is 5, right? So in fact the required vectors are plus minus 5i minus j minus 5k. So this is the required answer. What did we do? So what did we do? We were given that we were required to find out a vector of magnitude under root 51 which makes equal angles with the vectors a, b and c, and we were given vectors a, b and c. So we just assumed the required vector to be a vector r, which is xi plus yj plus zk. Then obviously its magnitude is 51, means x square plus y square plus z square is 51. Now r dot a was given to be modulus of r into using the formula r dot a is equal to modulus of r into modulus of a to cos theta. Using these we reached the conclusion that r dot a is equal to r dot b is equal to r dot c. So we have just applied the dot product of vector r and vector a, right? So we have obtained these equations. Then after this we have just solved out these two equations, taking these three equations in fact, taking twice at a time. Like first we took this and this, and then we took this and this, and we have derived the required answer. So the question was a bit lengthy, but it was quite simple. The next question that we have is, let beta is 4i plus 3j and gamma be two vectors perpendicular to each other in the xy plane. Find all the vectors in the same plane having projections 1 and 2 along beta and gamma respectively. So we are given beta is 4i plus 3j. Okay, now it's given that gamma is perpendicular to beta, right? So that means beta and gamma product, beta dot gamma should be equal to 0, and so what we can do is we can take gamma as vector gamma is, this is gamma, right? Vector gamma is 3 lambda I minus 4 lambda j for all lambda. So since it was given gamma and beta are perpendicular, so we have taken, first of all we'll get dot product as 0, since we have already discussed in the properties of dot product, and we can also take gamma as this value. Let the required vector, now we are assuming the required vector to be alpha equal to Li plus Mj, right? So I am assuming my alpha to be Li plus Mj. Then projection of alpha along beta. Projection of alpha, if I talk of along beta, would be equal to alpha vector into beta vector by modulus of beta vector, and that means 1 is equal to 4l plus 3m by 5, right? So alpha dot product of, I have taken the dot product of alpha and beta. My alpha was Li plus Mj, beta is 4i plus 3j. Dot product gives me 4l plus 3m by modulus of beta, that is magnitude of vector beta, that is under root of 4 square plus 3 square, that's 5. So this just gives me 4l plus 3m is 5. This is my first equation. Then similarly projection of alpha along gamma. Similarly again that will become alpha into gamma by modulus of gamma, and that gives me 3 lambda L minus 4 lambda M by 5 lambda, and that is equal to 2. So this gives me 3L minus 4M is equal to 10. This is my equation 2. Again alpha and gamma, gamma is my this, alpha is Li plus Mj, dot product gives me 3 lambda L minus 4 lambda M divided by modulus of gamma, that will be 3 lambda square plus 4 lambda square under root, that will be 5 lambda is equal to 2. It's given that the projections are 1 and 2 along beta and gamma, right? So we have reached two equations in L and M. So now you can just solve out these two equations to get the values of L and M. Solving 1 and 2, we get L equal to 2, M equal to minus 1, and therefore alpha was Li plus Mj. So I have Li plus Mj, 2I minus j, right? So we have obtained our alpha as 2I minus j.
Well, I hope you must have understood the dot product of two vectors. Now in the next session we will be switching to the cross product of two vectors, in which we shall discuss if we are supposed to calculate A cross B, then how exactly are you supposed to do it. We shall also discuss some questions based on the concept. So stay tuned.